Hello everyone. In this video, we will continue with the integrals of transcendental function. For this particular question, the transcendental function involving the e raised to certain exponent. So I can tell everyone that the fast rule for this is whenever you see the integrand that involving the e, you have to use the substitution method. Okay, using the substitution method means you have to let u equal to something. So in this case, I strongly recommend that you will let u equal to the exponent of e. Why do I suggest that? Because on the formula sheet that I'm given to everyone on here, you will see that you can work with the integral of e raised to exponent u du is equal to e raised to exponent u plus c. So you can go ahead and apply these formulas. Okay, so get back to our example. You probably asked me this question. You probably asked me this. You say, okay, so what happened to this then? What is the cube root of x squared here? I got so confused, okay? So if you just apply the fast rule that I just showed you, okay, so that means that you let u equal to the exponent of e. So right after you let u equal to the exponent of e, you have to differentiate, right? Excuse me. I'm sorry, so let me drink some water. So when you let u equal to the exponent of e, and you differentiate that, somehow it will involving this complicated exponent or this radical that they gave you here. Okay, so let's write down what formulas that we are going to use. So we are going to use the formulas e raised to exponent u du equal to e to the u plus c. Alright, okay. So I'm going to target that formulas. So using these formulas, it means that I need to let u equal to this exponent of e. Okay, so one more thing I would like you to take a look at this integrand. You see, these formulas say that you are going to integrate e to the exponent u du. In this case, that e to the exponent u divided by 1. But this one you have a denominator, but you somehow need to change that into a numerators. So changing this to a numerators, then remember these formulas. 1 over a to the exponent n, you make that into the negative n. Okay, so I can write my integral like this. So I may as well bring 2 across the integral sign because that's a constant multiply by. Okay, I will bring this e up and make that into the subtract cube root of x, right? Okay, then I multiply that with the dx divided by a cube root of x squared. Alright, okay, so basically what I have done is I apply these formulas so that I can have e raised to this exponent as negative, so that e is not the denominator anymore. You must have e as the numerator. Okay, so now because I say I'm going to apply this formula, so I will let u equal to this exponent. So before we do that, we are going to convert this radical to the exponent. So this could be 2e to the negative of x raised to exponent 1/3. Okay, so negative of cube root of x, so negative x raised to exponent 1/3. So here I should write just dx, and here I should write x raised to the exponent 2/3. Okay, you don't need to bring this up. Just leave it the way it is now. because later on you know that when you let u equal to this exponent, that means you have to differentiate. Once you differentiate, it will reveal this exponent for you so that you can match the differential factor dx with the du. Okay, so I'm going to let u equal to, I will let u equal to negative x to the 1/3. Okay, so when I've done this, it means that I am going to differentiate. As soon as you let u equal to, the very next step is to take derivative of u. So derivative of u, I will write du over dx. Okay, so this I will take the exponent multiplied by the coefficient in front of x. That will make that as negative 1/3. Immediately after, I will take 1 away from the exponent. Okay, so that is the derivative. Okay, so negative 1/3 x minus 2/3. Okay, so when I write this, I can now convert that into negative 1 over 3 times x to the exponent 2/3. Okay, so I will bring this down to the denominators. So when I bring it down to the denominator, I can change that to a positive exponent. So now you can see that the dx over x raised to exponent 2/3 will match with this now, like, right? So the next step is to manipulate this ratio. Okay, manipulate this ratio. I will take this time negative 3 times du equal to dx divided by x raised to exponent 2/3. Okay, so let's see what we have. So right here, I have done all of this stuff. And then, you see, I am having this as the exact match with this one. You see, exact match. So instead of writing dx divided by x raised to exponent 2/3, I will replace this whole expression by negative 3 times du. Okay, so that is the substitution method. So now I can write 2 an integral of, now e, okay, what do I let u equal to? U equal to this whole exponent, so that will be e raised to exponent u times what? Time, instead of dx divided by x to the 2/3, I will write it as times negative 3 times du. Okay, so now I will bring the negative 3 across the integral sign because they are multiplication. So bring the negative 3 across the integral sign, so I multiply by that. So what do I have left? Okay, you mark the exact formulas that you want to apply. So, and what does this integral become? It's just e raised to exponent u. Okay, so I should have it as negative 6 times e to the exponent u plus c. Now you substitute u back as x. So negative 6 times e, and what do you let u equal to? You let u equal to this. Here, you let u equal to this. So therefore, you are going to write it as negative x raised to exponent 1/3 plus c as your final result. Okay, and if you cannot write it as the negative exponent, so what you can do is negative 6 divided by e raised to exponent x 1/3 plus c, or it can be written as negative 6 over e to the cube root of x plus c as the final answer. All right. Okay. So let me go over this one more time. Okay. So if you don't want to hear me repeat this, you can just skip through. But I just want to spend like 2 or 3 minutes to go over this question one more time. Okay, so I don't go over detail, but go over the strategy. So when you see an integrand like this, you may get confused. It's that, oh, this is too complicated. It has this, and then it has this as well. Okay, so whenever you see that there's an e raised to certain power, the fast rule for this, or the strategy for this, is to let u equal to the exponent of e, and the rest will take care of itself. Okay. Um, I can tell you this, the more complicated the integrand, the easier it is for you to integrate. So whenever you see a complicated integrand like this with all kind of exponent, radical, then in fact everything is set up behind the scene for you to integrate. Okay, so if you let u equal to this exponent of e, okay, then what you need to do is you have to think this, okay, why do I let u equal to the exponent of e? Because I want to target this formula. Okay, when you target this formula because you want to apply this formula, then e raised to exponent u times du is e raised to exponent u again plus c, the exact same thing again plus c. So in this particular integrand, you have e as a denominator, which you have to make that into a numerator before you can apply this. So make that into a numerator, so that means I convert that into a negative exponent of e. And I will let this whole exponent of e equal to u. After I let u equal to, substitution method means I must differentiate. Okay, apply the formulas for differentiation. Multiply the exponent to the coefficient and subtract 1 from the exponent. And once you've done that, you see that the x to the negative 2/3 review, you bring it down to the bottom. And what you do in this case is you're going to manipulate this ratio. Manipulate this ratio so that you can match with your differential factor right here, dx divided by x to the 2/3. So they are exact match. They are exact match so that instead of writing dx over x to the exponent 2/3, you could write it with the expression on the other side of this equation, which is negative 3 times du. And then you replace the e to the exponent of x, you replace that with u. Bring this across the integral sign. Now you have these formulas to apply, right? So this formula is integral of e raised to exponent u du is just e to the exponent u. Then after that, you can substitute the value for x back into u and get the final result. Okay, so I just write a few different results here. So in here, I have to write this as positive exponent. So that means you take that negative away, you bring it down. And if you don't want to write x to the exponent 1/3, you can write q root of x. Okay, so let me fix this very quickly so everyone know that x raised to the exponent 1/3. Okay, so this is x raised to the exponent 1/3. So that means e raised to the exponent q root of x. Okay. So I do have time. So let me continue with the next question. Okay. So now you see right here, you also have e raised to the exponent something. Okay. So in here, you have e raised to the exponent. So right away, I said that let u equal to the exponent of e. But in this case, you have e raised to the exponent. But if you let u equal to 2x, okay, then it doesn't do anything. What happened with this? So whenever you see something like this, you have to go back and think of the very first few lessons that you learn in integration. So this is a function raised to a power. Okay, this is a function raised to a power. Whenever you have like a function raised to certain power, you immediately let that function equal to u. Okay, so the formulas you need to think of right now is u raised to exponent n. Okay, du will be un plus 1 divided by n plus 1 plus c. So the very basic uh, integration method, add 1 to the exponent divided by the result. Okay, then because you have a function raised to exponent, so right here you have a function raised to exponent. You have a function 2 times e to the 2x subtract 1. Cube root of that means you raise that to the exponent 1/3. Okay, so what you need to do in this case is you are going to write it as integral of 2e 2x subtract 1, all of it raised to the exponent 1/3, and I write e raised to the 2x dx at the end, because I know that this will become my differential factors. Okay, so the fast rule now that you have to remember is if you have a function raised to the exponent, you immediately let that function equal to u. If you just have e multiplied by e, some function multiplied by e raised to certain power, then you should let e, the exponent of e, equal to u. But if you can quickly do apply that strategy here. If you let u equal to 2x, what is the derivative of 2x? It's just 2. It didn't help at all in case of the substitution rule, right? Okay. So now I'm going to let u equal to 2 times e to the 2x subtract 1. Okay, so then du over dx equal to, okay, so what is the derivative of e? That means we have to go back and review our derivative of e. So right here, go back to our formulas. I provide 2 pages and they come together. Derivative of transcendental function immediately after I give you integration of transcendental function, because they go together. Okay, so right here, what is derivative of e raised to an exponent? So this formula is number 13 is the derivative of e raised to exponent u, so the eu again, but you must multiply by derivative of the exponent of e. Alright, so let's get back to our example, and we will continue to differentiate. Okay, so that means I will have the exact same thing again. So I have 2e to the 2x, right? But I must multiply by derivative of this exponent. Derivative of 2x is equal to 2. So I must multiply this by 2. And what is derivative of negative 1 is equal to 0. So du over dx will be equal to 4 times e to the 2x. So what you have to do next is you need to match the differential factor. So you need to have this. Okay. So therefore, I will take du divided by 4 e to the 2x times dx. Okay. So doing this, I know that now this is already matched with this. So I can write my integral as integral of you let this equal to u, so now it becomes u raised to exponent 1/3 times what? Instead of time e 2x over dx, you need to have the differential factor in term of u, so I will write it du over 4. Okay, now bring this across the integral sign. That means a quarter, right? So 1/3 du. Now we can go ahead and integrate this. So integrate this, that means I add 1 to the exponent divided by the result. Okay, so 1/3. I add 1 to the exponent. What is 1 plus 1/3? 1 plus 1/3 is 4/3. Okay? Divided by 3 over 2, divided by 4 over 3, that means I multiply by 3 over 4. Okay, I'm sorry, I just read the wrong fraction here. Okay, so now 1/3 plus 1 is 4 over 3. So divided by 4 over 3, it means you multiply by 3 over 4. Okay, so plus C. So simplify this, I should have a 3 over 16 U 4/3 plus C. So now I'm going to replace this by the function U that I let it equal to. So 2 e to the 2x subtract 1, all of it raised to exponent 4/3 plus C as the final answer. Alright, very good. Okay, so let me circle this because this is what we need to apply our substitution method. So substitution method is to let U equal to a function, differentiate that so you can pull out and match your differential factor. Okay, so here I got e raised to exponent 2x times dx. I have e to exponent 2x times dx. Instead of writing it as a function in terms of x, I will make that into the function of u. So in this case, equal to du over 4, so I multiply by du over 4. Okay, then I apply the basic rule for integration, add 1 to exponent divided by the result. Then that's what I have, simplify and substitute it back in. Alright, I think I do have time for another example. So that means question number 4. Okay, so for this question, okay, so we now dealing with the trigonometric function. Okay, so whenever you work with trigonometric function, again, what you need to do is you need to find the u, okay, and then you have to use the substitution method. So if you have a trigonometric function raised to a certain power, then you are going to pick that trig function and let it equal to u. Okay, so if you pick let u equal to cos of x, okay, so you are going to let the function let the trig function with the power equal to u. Okay, so that is the very fast rule that I would like to, or a hint. Okay, it works most of the time. Okay, however, if you have a square, then you have to be careful. Okay, so let's go to our formula sheet. I can tell you why I ask everyone to be careful. Okay, so if you go to integral of transcendental function, you will see right here, if you have a square, then it means secant square. So you can go ahead and apply this and let u equal to the argument of that function, right? Let u equal to the argument of this function if you have a square. But in this case, do you have a cos to the exponent here? No, you don't. You have sine, you have cos, you have secant square, you have secant square, you have secant times tan of u, you have cosecant times cotan of u, you have tan cotangent secant, and you have this, right? But do you have cos raised to exponent a half? No, you don't. Okay, so therefore, you have to let the exponent, the function with the exponent equal to u. Okay, then after that, what you have is you will have u raised to that exponent so that you can integrate. So I'm going to let u equal to cos of x. Okay, so you have let u equal to cos of x, so immediately you can write u to the exponent a half, right? Because you let u equal to cos of x. So what you have to write next is you need to have something to substitute in here in terms of with the du in here. Okay, so I can give you a hint with the du. How do you get that du? You have to differentiate the u. So du over dx, what is the derivative of cos of x? Okay, so I let everyone review that for yourself. So the derivative of cos of x is negative sine of x. Okay, so then you have du divided by minus 1 will be equal to sine of x times dx. So why do I do that? Because I want to match this one. Sine of x, sine x times dx. This is my sine x times dx, the exact match. So once I have that exact match, so what do I do next? So this part in here will become times du divided by minus 1. Okay, so this will become u to the a half times du divided by minus 1. Okay, so when it's time du divided by minus 1, bring this across the integral sign. It's the same thing as I multiply by minus 1. Divided by minus 1, the same thing as I multiply by minus 1. Okay, so then I have u to the a half times du. So I can go ahead and apply the basic rule for integration. That means that I add 1 to the exponent, and then I divide it by the result. I add 1 to a half. What do I have? A half plus 1 is 3 over 2. Okay, a half plus 1 is 3 over 2. So u raised to the exponent 3 over 2 divided by 3 over 2, it means I multiply by 2 over 3. So this will be plus c. So I will write it as negative 2 over 3. And I replace u back with cos of x. 3 over 2 plus c, and this is the same as I'm writing it like this. Cos 3 over 2 of x plus c. Alright, so that and that are two solutions. Two ways of writing the solution. Only one solution, but I can write it like this. Just to remind everyone, I write it like this to remind everyone that you must have the exponent outside the brackets here because you raise this whole function to this exponent. Okay, so you don't have the bracket, this exponent will read at the exponent for x. Alright, and this one, the same thing as you write cos to the 3 over 2 multiplied by x. Okay, so I have a 1 minute left for me to review this for you. If you have a function raised to an exponent other than like the square, if secant square, cosecant square, then you may just use the formulas given to you, but you have cosine, then cosine raised to certain power, so the best is to let that trigonometric function equal to u. Okay, then you differentiate to figure out your differential factor, and now your function turned into u to the exponent a half, then you can go ahead and integrate. Alright, thank you.